because when we get to word problems, you need to understand what that slope is telling you. It is the steepness of that line, okay? We already said all of this. The rise is the difference in the y values, change in y. The run is the difference in the x values, change in x. And slope is the ratio of the rise to the run. And this is your equation for your slope. So you guys already had all of that listed on the board. And so let's calculate a couple slopes. It says, first of all, use the slope formula to determine the slope of each line. And yet the only line they name is AB. So the only one I'm making you do at this moment is AB. You shouldn't have to calculate anything. It's just 0. Make sure you put that m is equal to 0, not that the line is equal to 0. The line doesn't equal 0, its slope does. Okay, so it's not AB equals 0. Okay. What is another way, if we have a picture of a graph, that we can get the slope without using the actual formula? Okay, so you can just count the rise over the run, right? But sometimes it's not the fastest way to work the problem if it's not graphed for you already. You may want to just plug it into the formula. But we could definitely find the slope of AC just by counting the rise and then the run, right? And it's rise over run every time. Okay. We already talked about how there's one kind of line that has an undefined slope. What kind of line is that? Vertical. And the reason why is because if you have a vertical line and you're talking about rise over run, there is a rise, but there is no run. And so you end up with a 0 down here. You could have any number on top depending on how far you're rising. But when you divide by 0 in math, that is always undefined. Okay? So it's always going to be undefined. Okay, so here's an example where they don't give you a picture and they want you to find the slope. So go ahead and calculate the slope using the formula. So instead of drawing a graph, use your y2 minus y1 over x2 minus x1. Tell me what you get. Okay, be careful. You. Yes, ignore me. Perfectly right, Ridley. All right, so I'm hearing a lot of people say the answer is 2, and that is correct. Slope should be 2. Any questions on slope? Okay. We already talked about this chart, positive, negative, 0, and undefined, but that is in your notes there. Okay. The one thing that we didn't talk about is when we get to those word problems again, we said that the slope is the steepness of the line, but it is also called the rate of change. Super important when you're dealing with word problems that you understand in the word problem, if they give you a rate of change, meaning something like miles per hour, that's a rate of change, that is slope. Does that make sense? Okay? Super important. All right, so then we look at this problem. Go ahead, you and your partner, and see if you guys can come up with an answer for this. Over 3, and that gave you 65 miles per hour. That is not a good enough answer. It says find and interpret, which means you need to give me a sentence starting with a capital letter, ending with punctuation that explains in context of this problem, what does 65 mean? So what would be your answer here? And who's he? So Justin is driving, that is driving 65 miles per hour. Okay, so just explain in context of the problem. If it says interpret, it means what does that mean? What is 65 telling you about this problem? Okay, miles per hour, rate of change, that is slope. And it does tell you, right? I mean, pretty much. But you just need to give me a good sentence if it says that. If it just says find slope, you can just give me the number. Okay. Parallel lines, you already told me that parallel lines have the same slope. Keep in mind, vertical lines have an undefined slope, but they're still parallel to each other. They both have an undefined slope. So that's why they said any two vertical lines are still parallel. Okay? Perpendicular lines, you did not know everything about. Perpendicular lines you said have opposite slopes, but what you didn't include was that they have opposite reciprocal slopes. So go back to your notes on your separate sheet of paper where you kind of made of this I already know stuff. Perpendicular lines have opposite reciprocal slopes. What does reciprocal mean? You flip it. So opposite means to do what again? To change the sign, and reciprocal means to flip the fraction. So if this line has a slope of negative, or that'd be positive 2/3, what's the slope of this line if it's perpendicular? Okay, -3/2 or -3/2. So you're going to change the sign and flip the fraction. Okay, if they are opposite reciprocals, then the lines are perpendicular. If they have opposite reciprocal slopes, flip and change sign. So what does that mean about any product? If you look back at the slide that I skipped, where they actually explained it a little differently here, they're going to say if you multiply the slopes of any two perpendicular lines, so -3/2 times +2/3, what does that become? -6/6, which reduces to -1. And that's going to be true every single time. So the way they word it here is in a coordinate plane, two non-vertical lines, because if they're vertical, their slopes are undefined. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. But you don't have to memorize it that way. You can just think that perpendicular lines have opposite reciprocal slopes, okay? But just know that means if you multiplied them, you would always get -1, okay? We won't really be using them in proofs much. We'll be using them just in our algebraic solving for slopes and writing equations of lines. You won't need it for your proofs. I mean, you need to know that, but you won't have to memorize it for a proof. Okay? So for example, graph each pair of lines, use their slopes to determine whether they are parallel, perpendicular, or neither. I went ahead and gave you the graph to save time, but I want to warn you, I have had students in the past who went and plotted all of these points, U, V, X, and Y, and then just picked two to connect. Be careful. They're telling you to graph line UV, which means you have to connect these 2 points, okay? And then they're saying to draw a line XY, which means you have to connect X and Y. So don't just graph all the points and then just draw some lines. Make sure you're drawing the lines they tell you to. Does that make sense? Okay? So on your homework, are you going to need graph paper? Yes. Graph each pair of lines, then use their slopes to determine are these two lines parallel, perpendicular, or neither. Obviously, if you look at those two lines, what are they not? They're not parallel, but they could be perpendicular or they could be neither. Do not assume that they look like they're forming 90-degree angles. They have to have opposite reciprocal slopes. So you have to check their slopes. So let's find the slope of UV first. So UV. Find the slope. So do you guys want to just count rise over run from U to V? All right. So what is my rise over run? Okay, so it's a +3/1, agreed? Okay, now let's do the slope for XY. What's the slope going to be from X to Y? X to Y, be careful. Okay, be careful. We went up 2 and we went left 6, so that's a -6, which means it reduces to -1/3. Your slopes need to be completely simplified. So I have a slope of -1/3. It does not. A fraction, I have all the time, every year I have students who, I don't know if we do a very good job in the younger grades explaining that, but if I have a negative 1/3, that's the same as negative 1/3, which is the same as 1/-3. The entire number is negative. It can either be you put the negative with the numerator or the negative with the denominator, but the 1/3 is a negative number. It just can't go in both places because that would make it a positive. Okay? So, are these opposite reciprocals? Because one's flipped and they have opposite signs. So what kind of lines are these? Perpendicular. B. Yeah, so we could have ruled out parallel to start with, but then we didn't know if it was perpendicular or neither. And this is where they'll get tricky. What about, oh yeah, are these perpendicular? No. Are they opposites? But are they reciprocals? No. So be careful. Just because the signs are flipped doesn't mean that they're perpendicular unless the numbers are flipped. Okay? If the signs are changed and the numbers are flipped. Okay, what about this? They are perpendicular. Because what's the reciprocal of 1? 1. 1 is 1/1. If you flip it, it's 1/1. Positive 1 and negative 1 are reciprocals of each other. And the signs are different. So be careful. Okay? Those are some tricky ones. Okay, one other thing I want you to add at the bottom of your notes here before we go to 3-6 and I see what you know is some special lines that always mess students up. And I think we've already talked about that this year. But really quickly, actually I think it's in 3-6. I'm going to wait. Just kidding. So, back to your piece of paper where you're taking notes on everything you already know. We knew all of that over there almost. Now we're going to go to 3-6. Let's see what you know for 3-6. So first thing I asked was what was slope, and you guys gave me an equation. What equation did you shout out? Okay, y equals mx plus b. What is that? Okay, so m is the slope I heard, and b is the y-intercept. And what kind of form of an equation of a line is this in? It's definitely linear because this is x to the first, but there's different types of equations. So this is called the slope-intercept form of a line. So that is one way you can write it. Slope-intercept. By the time you get to calculus, Mrs. Stinnett is probably going to encourage you to not use slope-intercept form as often as the other kind of equation of a line, and you'll understand why when you get there. But I will tell you, this is only awesome if your y-intercept is a good number, because to graph this line, you have to plot the y-intercept. Well, what if your y-intercept is a fraction or it's a large number that's not on your graph? Then it's no longer the easiest way to graph your line. So the second way you can write an equation of a line is called point-slope form. Does anybody know the point-slope form? Nobody knows for sure? Okay, I'll come back to it. We'll add it in a minute, so we didn't know that. Let's go on to some special kinds of lines. So this is definitely, you said linear, but it is always going to result in a picture of a line that is either a positive slope or a negative slope, right? What happens when our slope is 0 again? It's horizontal, right? So let's look at some of our special lines. Like horizontal lines. I'm trying to write too fast. So you said horizontal lines will have a 0 slope, which we already reviewed over there. So what are the equation then for a horizontal line? Y equals, could be 0, could be 2, could be any number, right? What is this number that it's going to equal? The y-intercept. And what letter do we use for the y-intercept? B. So your equation for a horizontal line is y equals a number, but that number is always going to be the y-intercept. Speaking of y-intercepts, what are the coordinates for a y-intercept? 0 something, and that something is going to be that b value, right? So y-intercepts are at 0b. The equation for a horizontal line is y equals b. Let me take that. And let's go on to our next special kind of line. What's the other kind of special line? Not horizontal, vertical. What did we say the slope of a vertical line is? Undefined. So m is undefined. What's the equation for a vertical line? X equals the x-intercept, okay? And so in our notes, let's call that A. That's what they're going to call that. I'm going to put here that that is our x-intercept. It's going to be x equals a number, right? And that's going to be the number where it crosses the x-axis. And so what are the coordinates for an x-intercept? Good. Something, comma, 0, and we'll just call that something A for our x-intercept. Okay, good. So we know that. We're still not sure what point slope form is, but we'll come back to that. But we know that a y-intercept should be 0b. We know an x-intercept should be a0. We know horizontal lines and vertical lines do not fit the slope-intercept mold, right? They're special. Okay? Let's see what else. Okay, so let's go back to this idea of y-intercepts, x-intercepts. So we said that for two lines to be parallel, they have to have the same slope. But do they have the same y-intercept? No. What would happen if they had the same y-intercept? They would be the same line. Do you know what it's called when two lines are the same line? Okay, so I'm going to skip some room here. Parallel lines, we're going to come back to perpendicular lines again. But the kind of lines that we're talking about right now, we're not quite sure what the name is, but we know that they have the same slope and the same y-intercept. I'm going to slow down a second and make sure you have that copied down. We know parallel lines have the same slope, but you said they can't have the same y-intercept, right? Because if they had the same slope and the same y-intercept, they would be the same line. So up here under parallel lines, I'm going to put different y-intercepts. Starts with a C. Does anybody know what kind of lines they are if they are the same line? It starts with a C. Nope. Collinear means that they lie on the points that lie on the same line. It is co, though. It's not something we've talked about this year. Something you might have learned in Algebra 1. Okay, we'll come back to it. So we've got to come back to this. We've got to come back to that. I'm so sorry. Okay, perpendicular lines. We said perpendicular lines have opposite reciprocal slopes, right? We already said that on the other board on 3-5. Do they have the same y-intercept? Okay, it could. Think about your graph. Could you have two lines that are perpendicular that happen to cross at the same y-intercept? Sure. Do they have to? No. So they have to have opposite reciprocal slopes. They could have the same y-intercept. But they don't have to. We're going to come back to it. Okay, that is everything that is in 3-6 with the exception of the couple things we didn't know. So I'm going to hand out the 3-6 notes, and then we're going to go through those. I want to know how much you already know and how much I need to go through and explain more to you. No, you guys are awesome. Now, you may be wondering, why are we doing this right now? What has chapter 3 been about this whole time? Okay, we've started talking about parallel lines cut by transversals. So what they're going to do is put these together. And they're going to say, okay, we've talked about parallel lines in the terms of geometry and angles formed. Now let's connect it to our Algebra 1. Can you graph lines? Can you graph parallel lines? What do you know about parallel lines and perpendicular lines? Yesterday we learned about perpendicular lines and how to prove they were perpendicular. So now we're going back to the algebra. What's true about perpendicular lines? So we're connecting all of the graphing, writing equations, plotting points to the concept of parallel and perpendicular now. Okay? All right, so in the notes, here we go, 3-6. Again, I'll go pretty fast and then give us some time to coinciding it. Okay, so 3-6. Okay, I'm going to go pretty fast, so please make sure you're listening. I hit it twice. All right, so we said there's two forms, point slope and slope intercept form. But remember that if they are vertical or horizontal, we write those a little bit differently. Point slope is the form you didn't know. You will be required on this test to write equations in point slope form. So you will have to memorize this form, you will have to use this form, and if you use the other form, you will get 0 partial credit. I am testing your knowledge of the difference between the two forms. And like I said, point slope form, the reason this form is so useful is because what it gives you, by the way, here is point slope form. So let's go ahead and add it back to our paper. 1. So y minus y1 equals m times x minus x1. It is 1 point. And that's why it's called point slope. It's still giving you the slope, m, but it's giving you a point on your line, not necessarily the y-intercept, just any point on your line. You're going to have a number where there's the y1 and a number where there's the x1. You will not, I'm going to say it again, you will not have a number where the y and the x are. Those are your variables that write your equation that calculate every point on your line. Just like up here, you'd never have a number for y or x. You have a number for the slope, you have a number for the y-intercept, and then you have the equation to graph the line, right? Okay, so the great thing about this is it gives you just a point on your line instead of the y-intercept, which means you could use a point that's on your graph easy to get to, instead of the y-intercept, which may be at negative 523.76. That's not an easy number to graph. But maybe you have another point that is an easy number to graph. And so you can use that point and your slope to then graph your line. Okay? So you're not going to, because you're going to leave it in point slope form. So you're not going to distribute the slope. You're not going to add the y1 to the other side. If you did that, you would be putting it back into slope intercept form. You could, if you liked to graph it better in that form and it said graph it, you could distribute the slope and then add the y1 over, and then you would have it in slope intercept form and you could graph the y-intercept and graph the slope. But if it says write your equation in point slope form, you leave it just like this. No, you just plug in the point, plug in the slope, done. You're not solving for anything. You're writing an equation of the line. And so what you're going to find in calculus is that your numbers are not always these wonderful, awesome y-intercepts, and your problems get much more complicated. So point slope becomes your friend because now you can plug in just a point on your graph and your slope, and you're done with your equation. And you don't have to do anything else. So you're going to learn this is going to be a little easier to work with eventually. It's just that when you were in Algebra 1, let's try again. I bet I messed it up again. Okay, let's see if it's going to let me. All right, so everybody with me? Point slope form, super simple, gives us a point, gives us the slope. All right, we already knew slope intercept form. We already knew vertical lines are x equals a number, horizontals are y equals a number. We already talked about what a y-intercept looks like and an x-intercept looks like. So that's here in your notes as well. So now this is the hardest part of do you remember your Algebra 1? So some problems we're going to work through. Write an equation of each line in the given form. Be careful. Oh, I knew it was going to do that. Let me stop it and restart it. Talk to each other. Okay, let's try again. Here we go. Write the equation of each line in the given form. The line with the slope of 6 through the point 3, negative 4 in point slope form. Point slope form. So I'm going to remind you, if you put it in the wrong form, you will get 0 credit. Point slope form is y minus y1 equals m times x minus x1. You do not put a number in for the y or the x. Only the y1 and x1. Okay? So what number is going to go in for y1? Negative 4. This is our x1, y1. So we're going to put y. You have to put y plus 4. If you put minus a negative, I will count off because at this point we should know to simplify that. Shouldn't be plus a negative because the formula is minus. So minus a negative is a plus. Okay, equals, what's going to go in for m? 6, and then minus 3. So this is all you are doing. You are not distributing the 6. You are not putting it in slope-intercept form. That's it. Now, here's the part where students make a mistake. If I said to graph this, and I didn't give you this sentence, but I gave you this equation, you have to pick out the point to graph, and then the slope. So really quickly, right here on this example, I want us to do this. I'm telling you, this is the most missed questions on the test when it comes to graphing, is when they're in point slope form. What point, ignore this up here, look at the equation. So remember that the formula has minuses in it. So that means your x1 and your y1 are going to be different than what's in the parentheses. If it's a negative in the parenthesis, it's going to be a positive. If it's a positive in the parenthesis, it's going to be a negative. So your coordinate here is not negative 3, positive 4. Your coordinate is positive 3, negative 4. And also be careful, it's not left to right. It's not negative 4, positive 3. It's x, then y. That messes people up. So you'll go to positive 3, negative 4, plot that point. And then what do you do to create the line from that point? Your slope, which is? Okay, so that means we go what directions? Up 6. Okay, so 4, 5, 6, up 6, and then to the right one. And then we graph our line. Does everybody see how to graph with point slope form? Yes, draw all the way through. You want to do that if you had Mrs. Siegert, but you won't. But if you had her, I know you have me. You're so lucky. Now you'll probably be like, we're sick of you by then. But if you had Mrs. Siegert, she would, again, same as Ms. Hackett, so she's trying to prepare you for that, that your graphs go completely off your graph or all the way to the ends of your graph to show, okay? Not just a tiny little squatty line. Okay, moving on. These get harder. So this shouldn't be there. I just forgot to delete it. Did I take it off of yours? Okay, great. Okay, write the equation of each line in the given form. This time, they do not give you the slope. They give you 2 points, and they want it in what form? Okay, what slope-intercept form? Okay, what two things do we need to know to write this equation? Slope and y-intercept. Okay, how are we going to find slope? Okay, very good. So let's calculate it. Change in y over change in x. So what's going on the top here? 0 minus 2, and then on the bottom? -1 minus 1. Would it have mattered if I would have done 2 minus 0? No, as long as I did 1 minus -1. And so either way, we're going to end up with what as our answer? Good. -2 over -2, which is 1. Always simplify your slope. So I have a 1 going in for m. I'm going to leave my y, leave my x. And now I need to find b. How do I find b? Okay, does it give me b? No. No, what does it give me? It gives me the x-intercept. It does not give me the y-intercept. If it had given us the y-intercept, if you had a coordinate that said 0, comma, a number, and you noticed that, you wouldn't have any more work to do. You could just plug in that y-intercept, whatever it is. So what do I do when they don't give me the y-intercept and I'm trying to find it and I know my slope? Okay, we don't want to graph it because sometimes these numbers are not going to be whole numbers, and then graphing it won't be a good solution because we'll have a fraction or a decimal. Okay, so what do you, oh, you mean switch to the different form? No, because, well, you could. I'm going to come back to that. Let's look at it that way in a second. Graphing, though, Ridley, I want you to understand graphing would work as long as you get a whole number. Okay, so that's not a bad option, but it's not the best option, and these are going to get harder where you won't have good pretty numbers. Okay, so what did you guys do whenever you didn't know B? Can't leave it as B. You have to have a number. It would not give us an equation of a line if we didn't have a number. It's not 0. Javi? Say it again. Yx to 0. Okay, I'm going to tell you what you do. This is obviously not a skill you're proficient at right now, so you need to pay close attention, take good notes, and practice this. You will see several questions on your test over things like this. So if it says, write an equation of the line, you have to have the slope and you have to have the y-intercept if it says slope-intercept form. You are not done until you have a number for m and a number for b. Okay, think about what they've given you. They have given you 2 points that are on this line. X and Y stand for the coordinates of points on your line. So what you need to do is pick one of those 2 points and substitute them in for X and Y so that you can solve for B. And it will not matter which point you pick. Any point would work. So which point do you want to use? Okay, I heard the second one first. Sorry if you said -1, 0. So if we use this one, remember this is X, then Y. So what's going in for Y? 2 equals 1 times 1 plus B. So 2 is equal to 1 plus B, because 1 times 1 is 1, right? And then subtract 1. So B is what? 1. This is not your answer. Your answer is supposed to be the equation of the line in slope-intercept form. So what's our equation? Y equals what? 1x plus 1. So we found our slope was 1. We found our y-intercept was 1. So now we plug them in, and this is your actual answer. You do not leave a number for y or a number for x, because that would then no longer give you an equation that would calculate every single point on your line. You do not need the 1, and some teachers will count off if you put the 1 there. So you are correct that you could leave this as just y equals x plus 1. Yes, it is not necessary to leave the slope of 1 there. Okay, I want to go back to what Morgan said. So Morgan said, could we switch to the other form? If we switch to the other form, which we could, but we couldn't leave that as our answer because it specifically said slope-intercept form. So once we found our slope, we would still need to find out that our slope was 1. Then if we use the y minus y1 equals m times x minus x1, we would plug our 1 in for m. What would we do from there? to start writing our equation? Pick one of those points, which is technically what we just did there, though, right? We picked a point, plugged it in, solved for b. If you picked a point over here, so pick one, which one do you want to use? Okay, negative 1, 0. So then what's going to go in for y1? So we would have y minus 0 equals 1 times x minus, so plus 1. And then what is y minus 0? Just y equals, and then 1 times x plus 1 is just, if you distribute it, it's just x plus 1. But you would have to go ahead and get y by itself so that you have it in mx plus b form. So if you had picked a different one, I'm going to go back and change this. So let's say we use the other one, y minus 2, because the y has to go in for y. 1 times x minus 1. Then we would have to distribute. That would give us x. So this would still be y minus 2 equals x minus 1. And then we would have to do what? Add 2. So we would get y equals x plus 1. So we'd still get the same answer. So back to what you said, yes, you could totally do that, but you don't need to switch forms if you don't want to. Just pick a point, plug it in, solve for b. Either way would work. Just make sure your final answer is in the correct form or you won't get credit on the test, okay? Or the homework, so make sure it's on the correct form. Okay. Here's another one. Write the equation of each line in the given form. The line with the x-intercept of 3 and a y-intercept of negative 5. What form?
Slope 1. So y equals...
Move careful. What form?
Y minus y1.
Point slope. So y minus y1 equals m times x minus x1. Okay. This one's a little different because what are they giving us? X-intercept and y-intercept. Here's the most common mistake I see. I see students who do this. I have a point at 3, negative 5. That is wrong.
3, 0, and then 0, negative 5.
Very good, Edwin. Remember, an x-intercept means that's where it crosses the x-axis. So it's a point at 3 on the x-axis. Y-intercept is a point where it crosses the y-axis. So now there's a point down here at negative 5 on the y-axis. That is 2 separate points, not one point combined at 3, negative 5. That would be a point here. Does that make sense? So this is wrong. Don't ever do that. Do exactly what Edwin did and write them as ordered pairs. This is at 3, 0. And the y-intercept then is at 0, negative 5. And then it is a problem exactly like we just did in that they're giving you 2 points, find the slope, write the equation. This one's a little different because it wants it in point slope form, not slope intercept form. So let's practice. So let's find our slope. What's our slope going to be? Negative 5 minus 0 over? 0 minus 3. What's negative 5 minus 0? Negative 5. What's 0 minus 3? So that reduces to? Just 5/3. Leave every slope as an improper fraction so that you have your rise and your run. You never want to change your slope to a mixed number. That's not helpful for anything as far as trying to graph it. So leave it as 5/3. Okay? So we want it in this form. So we know this is going to go in for our slope. What's going in for y1 and x1? One of your 2 points, which means there's 2 possible answers here, but they give you the exact same line if you were to graph them. So you could either plug in the 0 and the 3. So 0 would go in for y1. So we would have y minus 0 equals 5/3 parentheses. Okay, and you would leave it like that, even though it's y minus 0 because it said put it in point slope form. So this is point slope form. Or you could have used the 0, negative 5. So what would you have there?
Y plus 5 is equal to 5/3 parentheses
and you would leave it like that. This is giving you a point and the slope. They would both be acceptable answers, and they look different, but if you were to distribute the 5/3 and solve for y, they would both turn out to have the exact same y equals mx plus b equation. Okay, and so they would be the same line if you were to graph them. Any questions on point slope form? Again, I would remind you, if I were giving you these equations and you were picking out the point, it's the opposite. So +3, 0, 0, -5. Okay, so make sure you're changing those signs. Sorry, Kaden. All right, go ahead and do this one on your own. See what you get. You can simplify that. What is this? What's 0 times x? Where did you get to? But where did you get to? No, you didn't. Let's see, 0 times 4 is 4. That's right. Thank you. Okay, let's see what you're doing. So I see a lot of people that started with slope-intercept form, y equals mx plus b. Making sure you get this form straight. What did you plug in for m? 0. What did you plug in for x? Because right now, right, if you leave it like this, you're not done because you haven't found b, right? So that was the first place we got stumped earlier, and you said, once we talked about it, we're just going to plug our point in for x and y and solve for b, right? So what am I plugging in for x? 4. And what am I plugging in for y? 6. Okay, because we're trying to solve for b. What is 0 times 4? 0 plus b equals 6. So what is b? 6. Now write your final equation. This is not your answer. Your answer is in slope-intercept form. So we have y equals, what's the slope? 0, x plus 6. Can we simplify that though? What is 0 times x? 0 plus 6. So it's just y equals 6. We did not need to do any of that work. Think about it. If you have a slope of 0, what kind of line should it be? Horizontal. And horizontal lines are always y equals a number. And if this is the point that it's going through, then you have this point. You have a horizontal line going through that point. It's always going to be y equals the y coordinate. If this had said a slope that was undefined, what would have been the equation? X equals what? 4. Because that means now it's vertical going through 4, 6. So the x value is 4. Does that make sense? Sort of. We'll practice that again. So if it had said undefined slope, it would have been vertical, and the equation for verticals are always x equals, and then it would be the x coordinate. If it says 0, that means it's horizontal, which is y equals, and so it's the y coordinate. Okay? All right. Shouldn't have too much left in the notes. Graphing. Let's just make sure you know how to graph again. Did I give you a graph? Okay, so on your homework, make sure you have graph paper. We'll just sketch one real quick in our notes to save time. So sketch yourself a graph.
So +3, -4.
Be careful. That wasn't correct, Edwin. What form is this in? Point slope. What is the coordinate of a point in this problem? Very good. -4, +3. Remember that this is always y minus y1 equals m times x minus x1. Since this is a minus, you have to change the sign to a negative. Since this is a minus, you have to change the sign to a positive. Okay? So you're going to graph that point, -4, 3. And then what do you do from there? Use your slope. And what's your slope? -2, which means to go what directions? Down, how far? And down 2, right 1. And so now we just graph that line. You should use a solid line. I don't know why I'm using dots. Oh, thank you. So sorry. How about -4, +3, and then down 2, right 1. And left 1. And that's fine too. Does not matter. Just go one direction negative if it's a negative number. Any questions? Okay. What's left in our notes?
Parallel line.
Okay. So we already talked about this, but this was the thing that we left off was coinciding. We said if they have the same slope and the same y-intercept, they were the same line, but we didn't know the name of that. It was coinciding. Okay, that may not be something that you learned, and that may be new just for geometry, but add it because it will be on your test. So, coinciding. Another way they say it is coincident. Coincident lines. I don't know if you heard that or not, but they're coinciding or they're coincident, so they are the same line. If they have the same slope and the same y-intercept, they are the exact same line. Same slope, different y-intercept, they're parallel. Opposite reciprocal slopes could have the same y-intercept, it doesn't matter. Perpendicular. Okay? And that's what this chart's showing you. So determine whether these lines are parallel, intersecting, or coinciding. If they're in slope-intercept form already, then it's really easy to just look at their slopes. What's the slope of this line? 3. What's the slope of this line? -3. So do they have the same slope? No, one's positive, one's negative. So they're not parallel and they are not coinciding. Do they have opposite reciprocal slopes? Careful. They have opposite slopes, but what's the reciprocal of 3? The reciprocal is 1/3. The opposite reciprocal would be -1/3. If you flip 3, 3 is 3 over 1, so when you flip it, that's 1/3. Those are not reciprocals. They are opposites, but not reciprocals. So are these lines parallel, intersecting, or coinciding? They are one of them. Read the directions again.
Oh.
Parallel, intersecting, or coinciding. Okay, they're not perpendicular, but do they intersect each other? Yes. If they don't have the same slope, that means they're not parallel, so they're going to intersect. They just don't intersect at a 90-degree angle, so they're not perpendicular. So the answer is just intersecting. Okay, look at this one. It's different. One of them is in slope-intercept form, but the other one is not. What would we need to do first? Okay, how are we going to find the slope? Our slope is not -2. Yes, thank you. We need to divide everything by 6 and make sure you divide everything by 6 and not just the left side. Okay, you need to get it in slope-intercept form so you can pick out your slope. So y is equal to what reduced? -1/3 x plus 2. Good. Now compare them. Do they have the same slope? Yes, they have the same slope of -1/3. So what kind of lines are they? Maybe parallel. What did we need to check first? See if they're coinciding. Do they have the same y-intercept? Do they have the same y-intercept? No. So they are parallel. If they have the same slope, they're parallel. Okay, now we should be at our last example, right? Okay, so we're going to go through this together. This is word problems. You will see one just like this, a little different but similar to this on the test. Definitely. So if you like to write like I do sometimes, this is definitely on your test. Okay? Erica's trying to decide between two car rental plans. For how many miles will the plans cost the same? What has this entire section been about? Okay, not the whole thing wasn't about parallel lines. This section, what is this whole thing talking about? Slopes. What else? That was really mainly over there. What has this been about? Writing equations of lines, right? Slope-intercept form, point-slope form, horizontal, vertical, writing equations of lines. So if this is an application problem that goes with writing equations of lines, what do you think we're going to have to do here? Write an equation for a line, right? So it says Erica's trying to decide between two car rental plans for how many miles will the plans cost the same. And there's one typo. This mileage fee is 35 cents per mile. This one should be 50 cents per mile. They left off the per mile. Okay, so if she walks in to rent a car in Plan A, she's going to pay an initial fee of $100 and then 35 cents for every mile. If she goes in under Plan B, she pays $85 just to rent the car and 50 cents for every mile. Which of these pieces of information look like slope? Say it again, Bree. Exactly. Rate of change. This is a cost per mile. This is your slope, rate of change. And the initial fee, Bree said, is your starting point, which means when your x value is 0, it's what your y value would be. So that is your y-intercept. Does that make sense? Slope, y-intercept. So let's write an equation for each plan. Starting with Plan A. What would my equation be for the cost? So you can use y. I'm going to use c for cost. It doesn't matter. But this is Plan A. Cost equals what? 0.35x plus 100. Okay? The cost for Plan B. Y equals, or c equals, 0.50x plus $85. What are we trying to figure out? Okay, how many miles before they cost the same? So what would we need to do then if we want our costs to be the same? If this is supposed to be the same as this, what could we do with the rest of these equations? So if this is equal to c and this is equal to c, think about your geometry. You could use transitive to say what? They equal each other, because that's what we're trying to see. When do the plans cost the same? So when are they equal to each other? So we can say 0.35x plus 100 equals 0.5x plus 85. Sorry, running out of room there. Does that make sense? If they cost the same, then they should equal each other. Now let's solve for x, because that's what they want to know. How many miles? Does it make sense that our x value stands for the number of miles? We're paying 50 cents per mile and 35 cents per mile. So x is the number of miles. Okay, and c was our cost. So what do you want to do here to solve? Subtract. Okay, subtract 0.35x. Be super careful. That's going to give us 100 equals, what's 0.5 minus 0.35? 0.15. X plus 85. Subtract 85, what do we get? 15 equals 0.15x. So now what do we do? Divide by 0.15. How do you simplify that? You're right. What did you get? 100, because you're moving your decimal 2 places here, which means you're moving your decimal 2 places here. And 1,500 divided by 15 is just 100.
I remember this because of
Or you could divide it the long way, 0.15 into, and you could do that as well. Okay, what's our answer here then?
that is you need a switch.
This is a word problem. Let's write a sentence. So what are we saying? Okay, so the plans will cost the same at 100 miles. How much will they cost?
Can we just put that in facts?
Plug it in for X. So what is 0.5 times 100? Careful. 50. And what's 50 plus 85? 135. Right? Is that right? Yeah. My brain just went. Yeah. Okay, questions? All right, so here's the thing. You guys have homework that's due tomorrow and homework that's due Monday, but what's also happening tomorrow? Vocab. So make sure you study for your vocab test. Okay? What did I tell you? 23 or 29? I never told you? What? Ashley, get it together. 17. No, 17 words. The one I'm giving you right now. Now, heads up. What's happening on Monday? Your test. So if you wait